Continue with the 9.2 notes, and unfortunately, we did not have much time left for yesterday, okay? So, we're talking about how to quickly expand stuff like this really fast in our head, okay? So instead of doing x plus y times x plus y times x plus y times x plus y times x plus y, we're instead going to do what I'm about to show you, okay? All right. First thing I want to do, I'm going to use Pascal's triangle to do this. Here's what Pascal's triangle is, okay? Here's how I draw it. Okay? I draw the number 1, I draw the number 1. Okay? Underneath that 1, I draw 2 more 1s. I draw 2 more 1s. Okay? I draw 2, I have a 1, and then I draw 2 more 1s, okay? All right. The next row is going to have 3 numbers. Okay. The numbers on the outsides are always 1. Okay. The number on the inside right here in this space, I add these 2 numbers. It gives me a 2. Okay. Let's do the next line. Okay. A 1 here. A 1 here. Okay. The number, this is going to have 4 numbers. The number in this spot right here, I add these 2, it gives me 3. The number in this spot right here, I add these 2, gives me 3. All right? Does that make sense? Next line, right, my left and right numbers are 1. Okay? These 2 numbers I add together gives me a 4. These 2 numbers I add together gives me a 6. These 2 numbers I add together give me a 4. Okay? Let's do one more line, okay? So to draw the 6th line of Pascal's triangle, named after Blaise Pascal, okay? 1 on the left, 1 on the right, okay? These 2 numbers I add together gives me a 5. These 2 numbers give me a 10. These 2 numbers give me another 10. These give me a 5, okay? So that's how to draw it by hand, okay? You can do that indefinitely. What's up? Something funny? Yeah, no fine motor skills at all, sorry. My mom was talking to me. She's like, I taught you how to read, but you couldn't tie your shoe. She's like, remember kindergarten? You were reading at the beginning of the year, but you just couldn't tie your shoe. No. You guys want to call her? That'd be hilarious, actually. Should I give her a phone call and like tell her I love her or something?
Yeah.
If we were like not super far behind, I'd actually do it.
Come on.
So you love your precal academic class more than your mom?
What if you forget later to tell your mom that?
I tell her I love her like 5 times a day, probably. All right. So how does this relate to x plus y to the 5th? How does this relate to that?
It allows you to write it.
Plug it in.
Plug it in. Yeah, I just plug it in. Okay. So what's my exponent here? It's 5, right? So I'm going to go down to the 5th line. 1, 2, 3, 4, 5. Okay? I'm going to write out those coefficients. Okay? 1, 4, 6, 4, 1. Okay? You guys probably can't see that, can you? It's just nice dark. This one's nice and dark. So I write down the numbers on the 5th line of Pascal's triangle because my exponent is 5. Okay? Then what I do here, oh, is that a question? No, the first line's up here. 0, 1, 2, 3. Yeah, you're right. That would be 4. Sorry, thank you. Dang it. You're stealing my thunder. I was like, I'm about to nail this lecture, about to just no hiccups whatsoever. Sorry, yeah, thank you. You want to do the 6th line, right? Because n equals 5. This is the 0th line. The top line is the 0th line. Sorry. The top line is the 0th line. So I write it, same thing though, same thing, guys, come on. Exact same thing. Write out the numbers on that row. What? All right, what I do then, I start with an x to the 5th, y to the 0, okay? This is going to be 1 x to the 5th, y to the 0, okay, plus, okay, for that 5, on the 5 term, my x goes down by 1, my x exponent goes down by 1, my y exponent goes up by 1. So it's x to the 4th, y to the 1st, then plus 10 to the, what do you think is going to happen? X to the 3rd, y squared, right? X exponent goes down 1, y exponent goes up 1, plus 10 times, going to be x squared, y cubed, then x to the 1, y to the 4th, then x to the 0, y to the 5th. Okay, so that's how I expand that out really quickly. That's my answer.
Easy enough. Easy enough.
Yeah, easy enough. It's not, it's not trig sub institution integration. It's always tough. Okay, questions, comments, concerns? Okay, let's do these, right? A little practice. Expand. Expand x minus 2y raised to the 4th. Let me point. I'm going to do a lot of these on the whiteboard. Just been feeling more whiteboard lately. Trying to put out some quality content for my channel. Okay. Okay, so we want to expand x minus 2y to the 4th. So I go to the 4th line of Pascal's triangle. Which line is the 4th line? Yeah, this is the 0th line. The first one's the 0th. 0th, 1, 2, 3, 4. Yep. We go into that one. Okay, so write out 1, 4, 6, 4, 1. Okay, it's a little more fancy. It's a little fancier. Just treat the first term as x. Treat x as the first term. Treat negative 2y as the second variable, and I'll show you what I mean. Okay, so this is going to be x to the 4th, and then negative 2y times negative 2y in parentheses to the 0, plus x to the 3rd, negative 2y in parentheses to the 1, plus 6x to the 2nd, negative 2y in parentheses to the 2nd. Does that make sense? It does make sense? Okay. Dang it.
You just substitute the y, it'd be the negative 2y, and then the exponent.
So now instead of having just a y here, I've got just a negative 2y.
Yeah, that makes sense.
Okay.
It has the same exponent rule as before.
Yeah, it's the exact same exponent rule. Okay, so was the what about Pascal's triangle or some t?
No, I said, how do you what the numbers are?
What's that?
The 1s and 3s and 4, the exponents.
How do I know? Okay, so you have a question with the exponents. Okay, so my original problem has an exponent of 4. So my first term, I have my first term of my answer. I go to my problem. It's x to the 4, and then the second one to the 0. That's a minus 2y now. So I have to do times minus 2y in parentheses to the 0. And then my exponent is going to go down to the next term. My exponent on my x is going to go down 1 to 3.
Oh, so it's just like normal.
Yeah.
Down, but then,
Yeah. Good question. Good question. And then just simplify that with some algebra, right?
wait.
What's that? Yeah, it's not too bad. Anything raised to the 0 is just 1, right? So this just goes away. So I have x to 1, x to the 4th, or just x to the 4th, plus negative 2y to the 1. What's that? Negative 2y. 4 times negative 2 is negative 8. And then that's x cubed y to the 1. This one, what's negative 2y squared in parentheses? 4y squared, right? So 4 times 6 is 24. X squared, y squared, plus 24x squared, y squared. Yeah. You can do it. What's negative 8y cubed? Sorry, negative 2y cubed. Dang it. Negative 8y cubed, right? This is negative 8y cubed. 4 times negative 8 is negative 32. I have x to the 1, y to the third. Okay, x to the 0 just goes away, right? It's just 1. And then what's negative 2y to the fourth? Do you guys forget how to do that from algebra? Negative 2y to the fourth. So this is the same thing as negative 2 to the fourth times y to the fourth. 16 y to the fourth, yeah. You can distribute the exponent when there's a times in between. Yeah, so it's plus 16 y to the fourth. So that's how you do that a 1. That's how you do that one. Do I not combine them? Do I have any like terms that I can combine? That's a good question. Do I have any like terms up here that I can combine? What does it mean for two terms to be like to each other? They have the same variables with the exact same exponents. Okay? X to the third, y, these are not like terms. Because the variable, the exponents are not the same, right? This term has an exponent of 3 on y. This term has an exponent of 3 on x. So they're not like terms. No basket. Basket. Remember Bo Cooper at intramural basketball game? He waved the basket and it's so emphatic. It's like, dang, dude. I don't want to get a tech from him, man. Flagrant. Anyway, yeah, so that's how you do that one. You want to do another one? Let's do another one. All right. 2x plus 3y cubed. 2x plus 3y cubed. Okay, so my exponent here is 3, so which line of my triangle do I go down to? The fourth, the third line, here's the 0th line, the first line, the second line, the third line, right here, okay? So write out 1, 3, 3, 1, okay? Okay? The first term in the binomial is 2x, so I'm going to put that in parentheses after 1. The second term is 3y, so I'm going to put that in parentheses after that. All right. My original exponent for my problem is 3. So this first term, the 2x, gets a 3 on it. The 3y starts with a 0. Okay? And then I just keep going down the line. So now moving on to that second term here. Right? The 2x is going to get a 2. The 3y is going to get a 1. Moving on to the next term, we're going to have a 2x and a 3y, both in parentheses. The 2x is going to get a 1. The 3y is going to get a 2 for the exponent. Moving on to the last term, we're going to have a 2x and a 3y. The 2x is going to get a 0. The 3y is going to get a 3. That's how I do that. And then we just got to simplify. Just a simple song. There ain't much to it. All you got to do is doodly do it. All right, here we go. So this one, right, anything raised to the 0 is just 1, right? Goodbye. Okay. 2x in parentheses cubed, what's that? You cube the 2, you get what? You cube the x, you get what? X cubed. Okay. Moving on to here. 3, I cube the 2x, or I square the 2x, I get what? 4x squared. I square the 3y to the 1 is just 3y. So 3 times 4 times 3, that's 36, right? 36x squared y. Moving on to this, 3y squared, what's that? 9y squared. Okay. 3 times 2 times 9 is 54. Yeah, it's 54, right? xy squared. This last one, anything raised to the 0 goes away. 3y cubed, what's that? What's the 3 cubed? 27. What's the y cubed? It's just y cubed. That's my answer. Yay. So there you go. Questions, comments, concerns on that? This is important. We're going to end up doing probability with binomials. Okay? It's called the binomial distribution. It's when things get distributed in a binomial way. All right, I'm going to move on to the next one. What's up, Ian? I'm a little busy. Sorry. Okay. So find the fourth term of x plus y to the 10. Do you guys want to go all the way down to the... Are you okay if we draw 4 more lines of Pascal's triangle?
Yeah.
You are okay? Okay, yeah, you guys are supposed to say no. There's a quicker way to do this, too, which is good, okay? So let's think about this, okay? It's x plus y to the 10. Let's not worry about the coefficients right now. Let's just see what the variables will be. So the first term will give me an x to the 10, y to the 0, right? Then plus x to the 9, y to the 1. Then plus x to the 8, y to the 2. Then plus the term we're interested in. Well, I'll hold off. This will be plus x to the 7, y to the 2. Okay? And then there'll be a bunch of others, but we don't care, right? Because we have our fourth term here that we're interested in, okay? That's what we're interested in. Again, there's going to be some coefficients here, right? Each of these terms is going to have a coefficient. We just don't know what it is. And we don't care because we only care about the coefficient of the fourth term here, okay? So there's my fourth term, right? I have the variables for it, so let's write that down as part of my answer. X to the 7, y squared, okay? Yeah, y to the 3rd, thank you, sorry. Dang it. Okay, I just got to figure out what the coefficient's going to be, okay? Any guess what it's going to be? Someone guesses this would be awesome. Okay. What I do is you see this 10 here? The 10 was my original exponent, right? And I want you see this exponent here, it's 7, this first exponent. I'm going to do 10, choose 7. That's going to be my coefficient. Okay. So math prob, go to the NCR, 10, choose 7, gives me 120. So this is 120 x to the 7th y cubed. All right. Questions, comments, concerns? Bless you. You're welcome. Just being courteous. Okay, let's go to the next one. Find the third term of my guy here, right? Find the third term of my guy. So we have 7 as our original exponent, right? That's our OG exponent, okay? 2x in parentheses to the 7, and then a minus y in parentheses to the 0, right? We want the third term. That's our first term, right? There's going to be some coefficient. Actually, it's going to be 1. We don't care, though, for now, okay? We don't care about that one's coefficient. Next term will be 2x to the 6, negative y to the 1. Good stuff, good stuff. That's the second term, right? We don't care. We don't care about that guy or gal. Next term's going to be 2x to the 5th negative y to the 2. We do care about this term, right? This is going to be our term of interest right here, okay? So we have part of our answer, right? We have that 2x to the 5th negative y squared, okay? What's the coefficient going to be, though? We're missing the coefficient. What's that going to be here? 7, choose 5, right? My original exponent was 7. The exponent here is 5. It's going to be 7, choose 5, which is math, prob, NCR. 7, choose 5. 21. 21. Okay. All right. So then we just have to simplify that, okay? Let's color code this. Okay, so 21 is just 21, right? 2x to the 5th, what's that? 32x to the 5th. Negative y in parentheses squared, what's that? Just y squared, okay. What's 21 times 32? I get 672. Final answer is 672. X to the 5th, y to the 7th. All right. Questions about that one? Sorry, I just messed up. Gosh dang it. I'm making the weirdest mistakes. At least they're like easily recognizable mistakes. I didn't get a lot of sleep last night. Sorry. Like 11:30. I had volleyball. And then I just didn't feel like going to bed. Nah, I was watching YouTube. I was watching Black and Red Pen.
You ever watch Daily Dose of Internet?
What's that?
You ever watch Daily Dose of Internet?
Yeah, I do.
I thoroughly enjoy it. You watch them every day.
All right. Any more time needed for this one?
Pretty simple.
Find the probability of rolling a die 5 times and getting exactly 1, 3. Exactly 1, 3. It's actually pretty easy when I tell you the formula. Okay. Hi, Ben, Jade. Let's get our phones away, please. Here, can you please remove your AirPod Pro? Thank you. I know they got the transparency mode, but it's still kind of distracting. Okay. Exactly 1, 3, okay? Rolling a die 5 times, getting exactly 1, 3. We want 1 and only 1, 3, right? Okay. So it's going to happen. Let's pretend that we get a 3 on our first roll. What's the probability of getting a 3 on our first roll? On just the first roll. So it'd be 1 in 6 for that first roll, right? Right? And then what's the probability for not getting a 3 the second through 5th rolls? It'd be 5, 6 for the second roll, 5, 6 for the third roll, 5, 6 for the fourth roll, 5, 6 for the 5th roll. Okay. So this is equal to 1/6 times 5/6 to the 4th. Okay. All right. Right, but the problem is not asking me what's the probability of getting exactly 1, 3 on just the first roll. It's any combination, any way I have of getting just 1, 3, right? So like I could roll my exactly 1, 3 on the second roll, or the third, or the fourth, or the fifth. So how do we take that into account? One second, Alberto. How do we take that into account? We do, right? There are 5 rolls I have to choose from to get my 1, 3. So I multiply by what? 5C1. 5 choose 1. Which actually I think might be 5. So you multiply by 5C1, math prob, 5C1, I got 5. So it's 5 times 1/6 times 5/6 to the 4th. Okay. Make sure you can do 5/6 to the 4th by hand. No, I'm kidding. All right, I'll just take it up here, Alberto. You need your calculator. Got you later. Thank you, sir.
I don't think I'm gonna make it through period.
You guys feeling okay about that?
No.
No? Okay, I appreciate the honesty.
I don't know where you got 5C, but I get there's 5.
5C, where I got that from, the 5C1?
5 is how many times you're rolling it.
Yeah.
Right.
So I want the probability that I'll get exactly 1, 3, just one of those 5 on one of those 5 rolls, okay? So I could get my 3 on the first roll, or the second, or the third, or the fourth, or the fifth. I've got to choose one to get my 3 on, and there's 5 to choose from. There's 5 rolls to choose from. Does that make any more sense?
So if you had to get 2 3s, it would be 5C2.
Yeah. Yeah. This next one's a lot easier. No 2s. So I'm going to roll a die 5 times. What's the probability that I don't get a 2 on the first roll? 5, 6. What about the second roll? 5, 6, right? All the way across. It's just 5, 6 to the 5th. Okay.
Just 5 choose 1 times 5 and 6.
All right, and then for this one, there's only one way to do that, right? There's only one way to do that. So I guess you would technically do like 5 choose 0. 5 choose 0 is doing your calculator, right? Out of the 5 rolls I have to choose 0 of them to get my 2, right? I don't want any 2s. So 5 choose 2. Or 5 choose 0, sorry, 5 choose 0. It's just 1. It's just 1, yeah. This just reflects the fact that there's like only one way to do that. There's only one way to roll no 2s. Does that make sense? Okay. No more than 1 4.
So it's the same thing as the first one.
So 0 4s or 1 4. Yep. 0 4s or 1 4. So no more than 1 4 means I get 0 4s or 1 for a single 4.
So 2 6.
So if I do,
1 6.
let's think of just exactly 1 4 first. Let's do a different color. Exactly one 4. That's going to be, I'm going to do what? I got to pick how many of the rolls to get my 4, and I'm picking from how many? 5. So it's going to be 5 choose 1, and then one of the rolls is going to be probability 1 6 of getting my 4. The other 4 are going to be a probability of 5 6 of getting my not 4. Okay. And then getting exactly 0 4s, right? I have 5 rolls and I'm picking how many of them to get my 4? 0. So 5 choose 0 times my 5 6, right? 5 6 to the 4th. Okay, and I'm just going to add these two. I'm just going to add them. What's up?
Is that to the 4th? Is it the 5th? It's backwards.
5 rolls. Yeah, good and better.
So we leave it like you're leaving it here?
No, but would you know how to do that in your calculator? Or you want me to show you?
Yeah, you just do the prop, math prop, isn't it?
Yeah, math prob 5C1, and then once bathroom. Yeah, you're good. Sorry, I thought I said yes. Yeah, so I would do. I'll just show you real quick. Math, NCR 5, choose 1 times right arrow. I like the box over box key. Oh shoot, no. Yeah, I need to restart. Right, then right arrow times left parenthesis box over box 1 divided by 6. Okay, left parenthesis box over box 5 over 6 to the 4th. This is how I would do it.
Is the fourth one outside of the fraction?
Yeah, sorry.
No, I'm asking. Just like, it does.
Goes on the outside of the fraction, yep. Good question. And then this is what? 5, 6 to the 5th.
Exactly.
Yeah. So 80% chance. So it's about 80% chance. All right, in this one, I'm about to introduce a new concept to you that's a total life hack. Okay, make your life right. Doctors, right, or dentists hate this one simple trick. Okay. Going on to part D, pain in the butt, right? At least 1/6. So we get 1/6, 2/6, 3/6, 4, or 5, right? We would have to do 5 choose 1 times, what is that? 5/6 to the 4th, right? 1/6 to the 1. This would be 5 choose 2. All right, who wants to do all that in their calculator? Who wants to, you want to do that? No, we don't want to do that, okay? So instead, right, instead of doing the probability of getting at least 1/6, this is equal to 1 minus the probability that we get no 6s. Right? So instead of doing at least 1/6, we can do the opposite and subtract that from 1. Okay? Right? They want the probability that we get 1, 2, 3, 4, or 5 6s. Okay? Instead of finding all 5 of those, I'm going to find the probability of the odd man out of getting that 0, and then I'm going to do 1 minus that probability. Okay? That's because there has to be a 100% chance, a 100% chance of getting like some number of 6s, right? We're rolling the dice, right? There's a 100% chance that we're going to get a result, okay? We can either get 0, 1, 2, 3, 4, or 5 6s, right? So the probability of getting at least 1, of getting 1, 2, 3, 4, or 5 6s, and the probability of getting 0 6s, those have to add up to 1. So we're going to do 1 minus the probability that we get none. So that is 1 minus, what would that be? How many? We're going to pick how many of our rolls. We have 5 rolls. We're going to choose how many of them to be 6s? 0, and then it'd be 5 6 to the 5th. 1 minus 1 times 5 6 to the 5th, which is I got 59.8%. Right? So if we have 100 people roll the die 5 times, we can expect about 59 of them to get at least 1/6. If we had 1,000 people, we can expect at least about 590 of them. All right. So on to this next part. Let's finish 9-2 before the end of class. Not that this would ever happen to you, but suppose for a minute you don't prepare, so you randomly guess on a 10 question multiple choice quiz. Each question has 4 options. Find the probability of getting exactly 7 correct. Exactly 7 correct, okay? Okay.
So is that
You're totally on the right track. Okay? So I have 10 problems. What's the probability that I get one, like for each problem, right? What's the probability that I get it correct? Yeah, 1/4. Okay? Alright. So I need to do 1/4 to the 7th. And this is exactly 7. So what would the other parenthesis be? What's the probability that I get one wrong when I guess?
3/4 to the 3rd.
3/4 to the 3rd. Okay. We have 10 problems. We have 10 problems. I'm going to choose how many of them to get correct? 7. That's my answer. Really good job. Really good job, guys. That gives me hope. Gives me a lot of hope. That our last math test ever will go well. That is our last test. Yeah. All right, so that'd be that one. At least 9 correct. So we get 9 or 10, right? What's the probability that we get 10 correct? So we're going to choose how many of the problems to get correct. We have 10 problems. We're going to choose how many of them to get correct if we get all 10 of them. 10. So okay, sorry, I didn't explain this. Okay, at least 9 correct is going to be the probability of getting exactly 9 correct, plus the probability of getting 10 correct. Okay, so what I'm doing right now, let's find the probability of getting exactly 10 correct. So I'm going to choose how many to get correct out of my 10? 10, so it's 10 choose 10, which is just 1. Times what to the 10? 1/4 to the 10. Okay? Then what's the probability of getting exactly 9 correct? I'm going to choose how many of my problems to get correct? 9, so 10 choose 9 times 1/4 to the 9 times 3/4 to the 1. So, and then the answer would be these two added up. I mean, these two added up, okay? All right. Yeah, thank you. I'll take it up to the front. Add it to the stack. Oh, you're trying to figure this out. So that's just a really small decimal. That's not an error. E. That's 9.53 times 10 to the negative 7. So that's 0.000000. It'd be about that. It'd be about just the probability. Yeah, it's just a super. I'm more interested in that you know how to do that.
So if we did this.
Yeah, I'm more interested in we'll worry about the calculator stuff later. Yeah. We'll worry about that on like yeah. All right, and then at least 1 correct, right? That's the probability of getting 1 correct, exactly 1 correct, plus the probability of getting exactly 2 correct, plus the probability of getting exactly 3 correct. Right, so do we want to repeat this 9 times? So what are we going to do? Were you about to say it, Ben?
Is it like 1 minus?
1 minus the probability of what?
10.
Getting 0 correct. Right? The probability of getting 0 correct plus the probability of getting at least 1 correct, they just have to add up to 1, right? You can't get 11 correct or negative 1 correct, okay? That breaks reality. What does that mean? Right? The sum over all the projectors is 1. Okay? So I'm going to do 1 minus, how do I do the probability of getting 0 correct? What's my coefficient? What's my combo? 10 10 choose, not 1. How many am I choosing to get correct? 0. 10 choose 0. And then times 1/4. Oh, no, it'd be 3/4, right? Yeah, it'd be 3/4. Probability of getting 0 correct? 3/4 to the 10. I want to calculate that actually. So that's about 94%. So I'm going to get at least 1 correct, probably. I'm not going to get 0. Yeah. 0.94. They'll have to add it to 1. You okay about this? No? Okay. You didn't give me like the right responses. Do it on your own with me, Mark. Alright, should probably go to 9.3 just because we're behind. We're going to skip this. This is why I skipped it, so we're going to skip it. For now. What?
Complete. Skip.
Yeah, we're going to skip the last part of 9.2. I like these proofs, but we should probably just pick the bare bones. Okay. All right. So we're going to talk about the difference between probability and odds. Okay. When you talk about probability, like the probability of something, that's equal to the number of possible successes over like the number of like the total scenarios. This will make more sense. It's just different ways of expressing the same thing. Odds are the number of successes, possible successes, over the number of possible failures. Let's do that real quick. So if I have a coin and I flip a coin, what's the probability that I get heads? Where'd that come from? 1/2, right? The total number of scenarios is 2, right? You get heads or tails, but only the number of successful scenarios, right, is just heads. So it's 1 divided by 2. Or what about a die? Rolling a 2. What's the probability of rolling a 2 on a die? 1/6, right? The number of successful scenarios is 1. The number of total outcomes is 6. That's probability. Okay, what about odds? What would the odds of rolling heads be? Number of possible successes, right? I get my heads, right?
1.
Yeah. Number of possible failures is 1, so that's equal to 1 to 1. Okay. In a die, it would be what? 1/5. 1 to 5. 1 to 5 odds. Okay. There you go. Okay, so we're going to talk about Maggie. We're going to talk about Maggie. There's no Elizabeth in here. We're going to talk about Maggie and Elizabeth's bags of M&Ms. It's really important to note that they're separate bags. Note that they're separate bags. What that means, and this will make more sense, they're going to be independent events when we pull from both the bags. They're going to be independent. Okay? Right? So, let's say I have Maggie's bag of M&Ms, I have Elizabeth's bag of M&Ms. Okay? Let's say I reach into Maggie's bag and I pull out a green M&M. Does that affect the probability for the other bag, right? It's not like I pull out a green M&M from Maggie's bag and like the yellows in Elizabeth's bag disappear, okay? I call an exorcist if that happened, okay? Right? They're independent events, okay? Let's start off small. Let's just do Elizabeth's bag. We're going to choose some candy from Elizabeth's bag. What's the probability that it'll be green? So 20%, right, 0.2, 20% of the bags in Elizabeth's green are M&Ms. 20% of the M&Ms in Elizabeth's bag are green. So what's this going to be? 20%, yeah, 20% or 0.2. If a candy is chosen from Maggie's bag, what's the probability it will not be yellow? It's going to be 1 minus. What's the probability that it will be yellow? 0.2, so it'd be 0.8. Or 80%. Okay? If a candy is chosen from each bag, what is the probability that they will both be red? Yeah, what's up? Yeah, same thing. Yeah. Okay, now what's going on here? Okay, since independent events, since they're independent, we multiply the probabilities together. Okay. So what's the probability of getting a red from Maggie's? What's the probability of grabbing a red from just Maggie's bag? 0.2. Are you guys okay with 0.2? Okay. And then what's the probability of getting one out of Elizabeth's? A red out of Elizabeth's? 0.3. And then the total probability, the probability that they'll both be red, I multiply these together. Okay, we'll stop there. Do the 9.2 homework for Monday. We'll pick back up with this. Really good work today, guys. What's this? This would be 0.06 or 6%. Monday, right? I don't see you Monday, do I? Tuesday. Go, thank you. Dude, how come I wasn't on that? Okay. You're hilarious.
You should have used it.
Terrible. Good work today, guys. This is success. Successful day.
Yeah. Yeah.
Dude, I love that kid.
Are the notes over here?
That kid is something else. Yeah, I'm gonna talk to this white real quick.
Where are they?
Notes. Where are the notes?
Section 1. It's section 1K2, right?
The ones that you missed.
No, the ones for Jack.
Yeah. You want to pass one out to everyone? You want one?
I can.
Thank you.
Yeah, I just put it on Joe's desk.
Yeah, just put it. You. Pass out homework number 1. As they come.
Whose bag is it?
What was that? Okay. That's how big it was. I'll bet you on the seat, just live guy.
Oh, really?
Like, what's the hardest shoes you have? Yeah.
Oh, yeah. Homework or both?
What?
Homework? Just homework?
Just pass out the homework.
Okay.
I just put the notes in. The notes in there. The notes in there if you want them.
Our pictures are 250, right? 245, yeah.
For what?
I'm about to go to sleep.
For golf? Who's rushing you? Wait, Matt, is it pictures at 245 or is the varsity going to touch one of the You tired?
Yeah.
Yo, who was confused? He was confused as frack on the homework.
I didn't remember how to.
I expected it. I expected it.
I need to take that.
Interesting. Yeah, okay. Alright, so we do calculator part. Get some people set up. Make sure you get the notes and the homework. If you want paper notes. No. Unfair advantage. You actually want to be unfair advantage. But let's have you go to backpack and phone. You need a calculator. I'm walking on sunshine. Whoa. I was thinking of getting here. Are you back in the water?
No, we have early dismissal.
Oh, what time?
Like 2:35.
That's awesome. Okay. It's alright. No worries. Jay, already turned your head.
I want you to.
No.
I want to make sure the Caribbean is fire too.
Thinking you own the place.
I think she'll get along.
It's all right. Anything you want to say? I remember that. You said the same way games, and I was like, or somewhere today. Alright, okay. Calculator? Your phones are both with you?
The wood one.
What's going on in adventure? That'd be really.
I actually wrote everything up.
It's over there.
Did he? He got big. I'm gonna
But
spray tan.
that way. That way.
No, like I didn't want to get rid of you. You told me yesterday that that's what you were
It was a joke, and it was like, I gotta be strict.
What'd you say?
I said, can I get a hat? I off the fail. I was like, can I get a hat?
No, like I took
Turn on for
the side.
half a second.
Yeah, 'cause if I thought you were like 50.
I was thinking that. Yeah, party in the back. So when you take pictures, it'll look like you're gonna put it more in there. I'm so worried.
Yo, you're the man. You're clutch.
I gotta see if.
Yeah, no worries if not. It's kind of a long shot. All right, anyone need a quiz? Anyone need a homework? Okay, let's get the old homeworks that we just did out, or that we just did. What's going to happen is I'm going to go over a couple of them. I'm going to go over the really hard ones. Because I didn't post a key for a while, I'll give you another day to do it. Okay? Yeah. What do you do together?
Sarah tried talking about you in my English teacher. Or not my English teacher, my English teacher. How old she's like, but just together.
Yeah, we were just going to see.
Oh yeah.
What else was I going to say? Now, other than that, yeah, so I posted the answer key and I posted a much better video. We had a 40-minute lecture in E-Period today. It's much better. Okay? It's just as things usually are in E-Period. Oh no, I never stopped recording.